Walk into any busy Ugandan market, and you are immediately surrounded by physical effort. Everywhere you look, people are lifting heavy bunches of matoke and straining to move goods from one stall to another. Imagine one of these vendors pushing a heavily loaded wheelbarrow. He is straining his muscles, digging his feet into the dirt, and sweating under the hot sun. But the wheelbarrow is stuck in a deep rut and refuses to move. Common sense tells us this man is working incredibly hard, but according to the laws of physics, he is doing zero work. Physics strictly defines work as a push or pull, called force, multiplied by the distance an object moves. The vendor applies massive force, but his wheelbarrow's distance is zero. Multiplying his effort by zero distance means the final work is zero. In this world, trying hard doesn't count if nothing moves. Effort without movement is just exhaustion. True work is the act of successfully getting an object from one place to another. If work requires movement, what actually gives the vendor the ability to apply that force in the first place? Everything comes from a chain of transactions. It starts with sunlight, which provides the energy for food to grow. The vendor eats that food, storing it as chemical fuel, which his muscles then burn to create the physical motion of his arms. This chain is a perfect example of a rule called the law of conservation of energy. It tells us that energy can't be created out of nothing, and it never truly disappears. It is only ever traded from one form, like the fuel in our food, into another form, like the movement of a wheelbarrow. Think of energy as a universal currency. Whenever we see work happening, we are watching the visible trade of that currency to achieve motion. We can see this trade-off clearly at a construction site. Imagine two builders, each carrying an identical 50-kilogram bag of cement up the same flight of stairs. Builder A takes his time, walking up slowly. Builder B is in a hurry and runs up the stairs as fast as he can. Since they both lifted the same weight to the same height, they performed the exact same amount of work. The difference here is what we call power. Power isn't about how much total work you did. It's the rate of spending that energy. It's like comparing someone who spends 1,000 shillings over a week to someone who spends it all in 1 second. The builder who runs is more powerful, not because he did more work, but because he spent his energy currency much faster. While work measures the final result of what you finished, power measures the intensity and speed of the effort it took to get there. Sometimes a job requires more force than a person can provide all at once. Lifting a heavy sack of maize straight up onto a high truck bed, for example, might be impossible for one person to do in a single burst. This is where a simple machine, like a wooden ramp, helps. By rolling the sack up the ramp, the job becomes manageable. But here is the secret. The ramp doesn't actually reduce the total amount of work. Lifting the sack straight up requires a lot of force over a short distance. Rolling it up the long ramp requires much less force, but you have to apply it over a much longer distance. The total work stays exactly the same. The machine is just stretching the effort out. By increasing the distance you travel, you decrease the amount of force you need to use at any one moment. You see this trade-off in the long handle of a water pump or a pole used as a lever. You move your hands a long distance so that the machine can apply a massive force over a small distance. Simple machines are like physical payment plans. They don't make the energy cost any cheaper. They just let you pay it off in smaller, easier installments of force. These principles don't just apply to muscles and ramps. They are the foundation for how we power the entire country. At the Owen Falls Dam, we use the weight of the Nile. That water has stored energy because of its height. As it falls, it exerts a massive force over a specific distance, which physically pushes against the turbines. That movement, that work, is what generates our electricity. For homes using solar panels, we tap directly into the first step of the energy chain. We are capturing sunlight, a source that naturally replenishes every morning, and trading it for the power to run a radio or light bulb. Whether it's water pushing a turbine or a vendor pushing a cart, the trade-off between force, distance, and energy remains the same. Understanding these laws helps us choose the right tools for the task. It allows us to see exactly how much energy a job requires and find the most efficient way to pay that cost.